This video is for the first part of 9.2 for my 0308 class. I just want to get the basic definitions out of the way for unions and intersections and solve some basic inequalities. I'm going to go over the bottom of page 82, that first slide there, and then the next two slides on the next page, 83, and then I'm going to cover the top of 84 and then one example. So I'm going to stop at example 11. We'll pick up at example 12 when you come back from spring break. So this is just to make sure that you get this idea down, because we're going to talk about compound inequalities. And there are two types of compound inequalities, and those are unions and intersections. So I'm going to talk to you about unions first, and then we'll go back and we'll talk about intersections. So I gave you a couple examples there and a definition of what it means for a union. So the way I would help you remember it, that the symbol that you have for union is a U, and union starts with a U. So U is for the union, which is just another way of a symbol that you use for the word or. So that's what we're talking about. When you see the word union or U, that just means or. So when you join a sentence, so same idea in English, when you join a sentence, you have compound sentences. You can join them in one of two ways. You can join them with an or you can join them with an and. And so we're going to talk about compound inequalities, which basically means you have more than one inequality. And so we'll talk about those that we join with unions and those that we join together with intersections. So if you think about the union, I gave you a couple examples. The union of the North and the South. When those two came together, they put those two together to form the United States. So they took every state in the North, every state in the South, they joined them together. The union of those two became the United States. If you have sets of numbers like you have down there, where I gave you the set A is 1, 2, 3, 4. The set B is 2, 4, 6. When you union those two sets, basically what you're doing is you're putting those two sets together. If you put those two sets together, A union with B, then what you get is you get everything in the first set, which is 1, 2, 3, 4, plus anything new that you pick up in the other set. Well, 2 we already had, 4 we already had. The only thing new we picked up was 6, and so the union of those twos would be 1, 2, 3, 4, 6. That would be the union of those two sets. On a number line, when you have a compound inequality, then the union of those two is going to be anywhere. So on a number line, and this is what you're going to need on a number line, the union is any part of the number line that is shaded one or more times. So if it's shaded one time or 2 times or 3 times or whatever, but in this case it's just going to be 1 or 2 times. Anywhere that's shaded one or more times. If it's shaded once or more than once, that part is included in the union of those two. So let me give you an example with some sets. So if you flip over, so I'm going to kind of flip around just a little bit. I want to kind of talk about the unions while I'm talking about them. If you flip over to page 84, if you look at example 9, so I'm going to number these by example. If you look at example 9 is a union because it says or. It says that T has to be less than 2 or T has to be greater than 7. So when I draw those on a number line, I'm going to draw them on the same number line because I'm talking about the union of those two. T less than 2. So here's 0. So up here is 2. T less than 2. I'd have a parentheses at 2, and then I'd shade everything to the left because that would be everything that is less than 2. Or T has to be greater than 7. So I'm going to do this in a different color. So here's 7, and I wanted to shade everything that's greater than that. So again, I'm going to use a parentheses, and I'm going to shade everything to the right. I need everything that's bigger than that. So the union is any part of my number line that I shaded one or more times. The portion here in black is the portion from negative infinity to 2. That was shaded one time. The portion over here in blue from 7 to infinity, it was shaded one time. So I have to include it in the union or the or. So when you see the word or, think about the union. I have to have a way, because those two pieces of my number line are not connected, I have to have a way to join those two together. And so the way we join them together in mathematics is we use the symbol for the union, and the symbol for the union is the U, and so there would be the union of those two sets written in interval notation. You have to write it as nice and succinct as possible. And I can't write that one any nicer than that, other than saying negative infinity to 2, union with 7 to infinity. Let me give you another example. Look right below that at example 10. Example 10 says I want to find where x is less than 7, or, so we're talking about the union, or where x is greater than or equal to 0. So, if I put those on a number line, so x is less than 7, let me do that one in blue. So x less than 7. So here's 0, so 7's here. And I want x to be less than 7. So x less than 7 would be everything to the left of 7. So there's where x is less than 7. Or I need x to be greater than or equal to 0. So here's 0. Got a bracket at 0 because greater than or equal to. And I need everything greater than that, so I'm going to shade everything back to the right. Now I have to write in interval notation, because your answer is going to be in interval notation for these. I have to write my answer in interval notation as nice as possible. So union is anywhere where I shaded one or more times. If you look, my entire number line is shaded one or more times. I shaded everything to the left of 7 in blue, then I shaded everything to the right of 0 in red, and so yes, I did overlap somewhere, but where I shaded one or more than one time is my entire number line. My entire number line is everything from negative infinity all the way to positive infinity, and that's as nice as I can write my answer, and so there's my answer. Your graph of your number line is going to lead you to the answer that you're going to write for me always in interval notation. One more example of a union. So look at example 11, and then I'll go back and talk about the intersection. Example 11 says that x is going to be greater than or equal to negative 4, or x is going to be greater than 3. So again, draw your picture. So here's 0. So I'm going to, in blue, I'm going to do negative 4. So negative 4. X is greater than or equal to negative 4. Got a bracket at negative 4. I'm going to shade everything to the right. So there's where everything where x is greater than or equal to negative 4. Or x is greater than 3. So there's 3. Got a parentheses. And I need everything that's greater than that. So I'm going to shade everything to the right of 3. Again, that picture leads you to your answer. So you have to write it as nice and succinct as you can. Anywhere on that number line where you shaded more than one time, or at least one time. So one or more times. So anywhere where you shaded one or more times. Where I shaded one or more than one time, I shaded one time from negative 4 to 3, and then I shaded more than one time from 3 to infinity. So where I shaded one or more times is everything from negative 4 all the way to positive infinity. That's where I shaded one or more times. And so there is as nice and as neat as I can write it in interval notation. It's from negative 4 to infinity. So sometimes you can write it as one interval. Sometimes, like with example 9, you're going to have to join it together, and the only way you can join it together is with a union. Okay. Let's talk about the intersection. So go back to page 83. Definition of the intersection of two sets. Are those elements that are common to both sets? So I gave you a couple examples. If you're the intersection of Highway 259 and Houston Street, if you're standing in the intersection, you're standing in both Highway 259 and Houston Street. So when you join something with an and, you're looking for the elements that are in both sets. You're looking for those elements that are common to both sets. So those two sets of numbers that I gave you, if you take the intersection, so when you see an upside down U, that means intersection. So remember the other one starts with a U, that's union. So the other one's intersection. Upside down U is the intersection. The word that we're talking about when you see intersection is the word and. You want those elements that are common to both sets. So if I look at 1, 2, 3, 4 and 2, 4, 6, and I want the numbers that are common to both sets, then 2 is in both of those sets, and 4 is in both of those sets. So there would be the intersection of those two. When you're on a number line, the intersection is where you shaded twice. Or if you want to think of it, it's where they overlap. So if you have two colors, it's where the two colors overlap. So for me, where my blue and my red are going to overlap, that is going to be the intersection of my sets. Okay, the rest of these examples are going to be intersections. If you ever see something written as one string of inequalities, so 3 less than x, x less than or equal to 5, those are always intersections. Anything written like that is always an intersection. It's never a union. The way we can write that, if we were to split it apart, is cover up the less than or equal to 5. If I cover up the less than or equal to 5, I have that 3 is less than x. Now cover up the 3 less than part, and I have that x is less than or equal to 5. So those are my two separate ones. And I would tell you to go ahead and get in the habit of doing that. If you go ahead and get in the habit of splitting them apart like that, then it's going to make more sense to you when you start trying to solve these inequalities. So now, this is where you need some of the stuff we talked about in 9.1. 3 less than x, I can turn that around. That's the same thing that's saying x is greater than 3. So I'm talking where x is greater than 3 and where x is less than or equal to 5. So now I'm going to draw those just like I've been doing. So here's 0. So I'm going to do this one. I'm going to do 3 in blue. So I need where x is greater than 3. So there's 3. Got a parentheses. Going to shade everything to the right. Excuse me. And in red here, I'm going to do everything where x is less than or equal to 5. So I have a bracket at 5. And I want to shade everything to less than that. So I'm going to shade back everything to the left. So that picture leads me to my answer that I'm going to write in interval notation. In interval notation, where I overlapped, where I shaded twice, where the blue and the red overlap. Where the blue and the red overlap is from 3 parentheses to 5 bracket, because the parentheses means I'm not including 3, so I technically only shaded the 3 one time. The bracket means I did shade it twice there, so that's why I'm putting a bracket at 5. So parentheses at 3, bracket at 5. Technically what you're supposed to do is you're supposed to redraw your number line. Now you don't have to for me, but when you're working your problems online and stuff, when you're choosing the correct one, technically what you're supposed to do is you're supposed to redraw it for me, so 3, 5, and then you have a parentheses at 3, bracket at 5, and you just shade the portion in there where we overlap. So that's what you want to choose if you're having to choose one online. And just another thing, if you prefer open and closed circles, you may see them as open and closed circles. So open circles would be parentheses, closed circles would be brackets, in case you happen to come across that. So be careful that you know the definition and you know the difference between intersections versus unions. So let me give you a couple examples here. So x being less than or equal to 4. So this is example 6. X being less than or equal to 4 and x being greater than negative 1. So when I draw this on a number line, x being less than or equal to 4. So I'll do this one in blue. So x being less than or equal to 4. So there's 4. Got a bracket at 4. I'm going to shade everything to the left of 4. That's where everything is less than or equal to 4. And where x is greater than negative 1. So we'll do this one in red. So negative 1, open parentheses. And I want everything greater than that. So I'm going to shade back everything to the right. So where I overlap, since I'm doing the intersection, where I overlapped was negative 1 parentheses 4 with the bracket. And again, I'm going to have you write them in interval notation for me. But again, like I said, technically if you were to redraw that on a number line, you'd have negative 1 to 4, and you have a parentheses there, bracket there, and you just shade everything in the middle. But for you, you're going to have to write your final answer in interval notation for me. The next example is just to help you to see that sometimes you don't have places where you overlap. So it says that x is greater than 7 and that x is less than or equal to 5. So if I draw those on a number line, so you've got to make sure you know the definition of and versus or, so be careful. So I'm going to do 5 first. So here's 5. I need everything that is less than or equal to that. So I'm going to shade everything to the left. And then 7. I need everything that's greater than 7. So I'd shade everything to the right of 7. And you see that I have no overlap. So there is no place on my number line where I shaded twice. There's no place where the blue and the red overlap. I went red one direction, blue the other direction. So there is no answer to this one. There is no intersection. There's nothing in the intersection. So if there's nothing in the intersection, basically what that means is no solution. There's not an answer. And the symbol that we use for no solution in mathematics, if you're typing it online, they may have you use a capital N, but the symbol that we use is a 0 with a slash through it, which means the empty set. It means it's a set with nothing in it because there is no overlap there. So just make you aware that sometimes that can happen to you where you get no solution. Doesn't happen a lot of times, but there are a couple of different cases where it'll happen to you. All right, and the very last one there, example 8. Example 8 says, we want to find out where x is less than 6 and at the same time where x is less than or equal to negative 3. So draw a number line. You're going to get tired of drawing number lines, but this is really the only way you can do it. So let me do it in blue first. So here's 6. So there's 6. And in everything less than 6, I'm going to shade everything to the left. And x needs to be less than or equal to negative 3. So here's negative 3 down here somewhere to the left of 6. And I need x to be less than or equal to negative 3. So again, I'm looking at wherever on my number line where I have an overlap, where I shaded more than one time. Well, if you notice that everything to the left of negative 3 is shaded twice. It's double shaded. It's shaded in blue and it's shaded in red, and it continues on forever. So where I overlap is this portion of my number line right here that I'm going to draw in black. That portion right there is where I'm going to overlap, where I shaded twice. So for me, in interval notation, that would be from negative infinity to negative 3, and since there's a bracket at negative 3, that's what we use. So we use a bracket at negative 3. So that would be where my overlap is. So what we're going to do with these compound inequalities is we're going to solve some compound inequalities, and then we're going to have to solve and write our answer in interval notation. And so I'll pick up after spring break on that Monday with example 12 here in 9.2. And that'll keep us on track to have time to get in all the tests that we're going to get in for the rest of the semester, and to make sure we have plenty of time to cover everything.